All right, let's get started. So I sent out the email yesterday. So I think some of the students still didn't get their AD2. So we decided extend the deadline for write-up 1 to next Tuesday. So it will be the same deadline for Lab 2. So if you are able to receive the AD2 like by tomorrow or at this weekend, you should still do the AD2 version modified task. But if you like cannot receive the AD2 like until next Monday, so you can do the LT spec version. Okay, so but I recommend you do the AD2 version because you will need to use AD2 in the future. All right. And hopefully you already submit your pre-lab for lab 2. Okay, remember that's still before start of the lab. Any questions before I start to talk about today's lab? Question. The there's a question about red for lab 1. So I think for lab 1 you only need to finish the write-up. Okay, so there's no pre-lab for lab 1. So the deadline is for the write-up. That's the only thing you need to do for lab 1. All right. Any other questions? All right. If not, let's talk about today's lab. So today's lab 2. Okay, so for lab 1, you already play with DC signal, okay, which means the voltage is constant with the time change. Okay, so if you have a for example in task 1 of lab 1, when you provide a 3 volts from your AD2 from the V plus pin, the voltage will be always 3 volts. Okay, but today's lab, you will start to play with AC signal, which means the amplitude will change with the time change. Okay. Hopefully, you already read through the lab manual for lab 2. And so when we talk about the AC signal, usually we represent the signal by this kind of equation. Okay, so and there are some variables you need to know. First of all, so this equation is 3 sine wave, 2 pi times 100t plus 1. Okay, so each number in here have different meaning. Okay, so start from 3. So that's the amplitude of your signal. When we transfer this to the port, 3 means the distance from the center point of your signal to the top point of your signal. That should be 3 volts. Okay. And then the sine means that's the shape of your function. Okay, so that means this is a sine wave, or sometimes this will be a triangle wave. You will need to draw a triangle wave. And the 100 here is frequency. Okay, so frequency is equal to 1 over frequency is period. So that's how you define the period, the time for one period. Okay, so from here to here, that's 1 period. So the time is equal to 1 over frequency. So for example, here is 100. So the frequency is 100 hertz. So the period is 1 over 100. That's 10 milliseconds. Okay, so if here is 1,000, 1 over 1,000 will be 1 millisecond. So that's the period. And sometimes there is a phase shift, but that's not common in today's lab, so I'm not going to talk about the phase shift. And lastly, there is a +1. So that's the offset, which means this number will define how your signal go up or go down. So for example, here, +1 means your whole signal will go up by 1. So that's why the top point in here is 4 instead of 3, because you have 1 phase shift So that will be the top point. 3 is your amplitude, and +1, that will be your peak point of your signal. And then similarly, the bottom point of your signal, if there's no offset, the bottom point will be -3 because 3 is your amplitude. Since there's the offset and the offset is positive, your signal go up by 1 volt, then the -3 move up to -2. Okay, so that's why you have this. Okay, so remember there's a practical in week 6. So this is the one thing you need to know. Okay, so when you have this equation, you should able to draw this plot. Okay, or when you have this plot, you should able to write down this kind of equation. Okay, so you need to transfer one to another one. And then another point is important for today's lab is RMS value. Okay, so there's a DC RMS and there's an AC RMS. The relationship is this. Okay, so the square of DC RMS is equal to square of AC RMS plus square of average. So usually the average is just the offset of your signal. Okay, so when there's no offset, your DC RMS is equal to AC RMS. And one of the and by the way, the AC RMS, you can find the calculation table from the table 2.1 in your lab menu. Okay, so when you know the AC and the amplitude of signal, and you find the corresponding equation from this table. And if you know the offset, you should able to calculate the DC RMS. Okay, and one of the important reasons we bring the RMS value is, so for example, in lab 1, you know this equation, the power equation, E equals to I times V. So that's for the DC signal. So for example, there's a resistor, you have some voltage cross that resistor, you have some current cross that resistor, then the resistor is consume power. So that's same thing for AC signal. Okay, so you will need to know the RMS value for the AC signal that cross the resistor, and you know the RMS value for the AC signal cross the resistor again. Then you know how much power dissipated by this resistor. So that's why we need to use RMS value. All right. Let's answer a question later. Okay, any questions for this part? I think this equation is related to your pre-lab question too. Yeah. Okay, if there's no equation, no questions, you can open the AD2 modified tasks for lab 2. Okay. We can talk about what we are going to do for today. Okay, so for lab 2, there are 3 tasks you're going to do for today. The first one is simple. So you will use your AD2 to generate an AC signal. Okay, so remember last week you used V plus, V minus pin generate DC signal. This week, for this question, you will use W1 and W2. Basically, they are same thing. Okay, so your AD2, one AD2 can generate 2 AC signal. Okay, so that's come from W1, W2, that's waveform generator. Okay, and then you will use your DMM to measure the signal. Okay, so the which means you will, for example, you use your W2 to generate the signal required from this question. Okay, 2 volt, 1 kHz, and offset of 2. Okay, after generating the signal, you will need to connect this pin to your DMM. Okay, so for your DMM, I assume you already watched the tutorial video. There are 4 pins. 1 pin is common. This common should be connected to ground of your AD2. And when you measure voltage, you will use this pin. There's a pin for voltage resistance. Okay, so that's a pin you will need to. And also the function. Well, when you measure AC signal, you will need to tune this thing to. I think the logo is something like this. Okay, so there's a wave thing. So that's this voltage. So that's means AC signal. Okay, so when you measure AC signal, it's a different pin from DC signal. Okay, so that's how you measure the voltage, and then you will, after you do the calculation, you will verify is this DMM measure AC RMS or DC RMS. And then you will repeat the same thing for another triangle wave. Okay. So that's question 1. The question 1 should be not too hard. Okay, so task 1. So then task 2, okay, start from task 2, you may need to use breadboard. Okay, so if you haven't watched the tutorial for breadboard, please watch through there's a link how to use breadboard on the Brightspace. So please watch through that video. After you watch that video, if you're still confused about the DMM, you can breadboard, you can let me know, or let another UTA know. We can help you to build the circuit on breadboard. Okay. So for task number 2, basically you will build this circuit on the breadboard. Okay, so the things you are going to do is you want to measure the current and voltage across this resistor. Remember, I mentioned last week, when you measure the voltage, the voltmeter is in parallel with the thing you want to measure. So in here, voltmeter is parallel with resistor. And when you measure the current, the ammeter is in series with your component you want to measure, because you want to let the current go through the ammeter. Then the ammeter can know how much current goes through the component. Right, so basically you will build something like this. And similarly, you will use AD2 to generate the AC signal, so which the signal is from your W1 pin. And also you will use DMM to as the ammeter to measure the current. Okay, so when you measure the current, you want the current goes through your DMM or goes through the ammeter. So there are 4 pins on your DMM. 1 pin is for voltage, which you already use. Another 2 pin is for current. Okay, so you will use one of them. Okay, so the one with amp is when you measure the large current. So that's one have a larger range, but less accuracy. When you measure small current, you will use, there's I think a pin for milliamp or microamp. That's measure for the range is the range you can measure for this is small, but the value will be not accuracy. Okay, so you can choose either one of them to measure the current. Okay, so what you're going to connect is firstly the voltage or the current comes from your AD2, and you want that current goes through your current pin of your DMM, and then the current goes through ammeter, and the current comes back to common mode. the common pin, okay? Then the common pin go to the resistor. Okay, so that's how your connection goes. So W1 to amp, and the amp go to the comp, and the comp go to the resistor. Okay, and the resistor go to one side of the resistor, another side of the resistor go to the ground. Okay, the ground pin will be either one of them from your AD2. All right. And then you will use AD2 to measure the voltage across this resistor. And remember, there on the left part of your AD2, there's the 1 plus 1 minus, 2 plus 2 minus. That's called the scoop. This 2 pin can measure AC signal and DC signal. Okay, so I mean DC, it can work as a voltmeter. So I assume you will use pin 1 as the voltmeter. So you will connect this 1 plus to one side of your resistor and 1 minus to another side of your resistor. And there's if you go to the waveform, there's a voltmeter function at left sidebar. So you will use that as a voltmeter. Right, so that's the connection or the schematic for task 2. After you measure the voltage and current, you will build like a data table similar with what you've done in Lab 1, and try to verify the Ohm's law. I think for this one, it's the first time you will build the circuit on breadboard, so I think you may have problem when you build the circuit. You can just let me and other UTA know, we can help you. Yeah, and any question for task 1 and task 2? No. Okay. Let's go to task 3. Okay, so task 3, you will build 3 different circuits. Okay, you will use a DC voltage source, okay, and 3 light bulbs, and also a photoresistor. Okay, and I will show you what photoresistor looks like, and it should be in your lab kit. Okay, so first schematic, you will build something like this. Okay, 3 light bulbs in series, and you measure the voltage and current across each light bulb. And since you know this 3 light bulb is in series, and then the current goes through each of them, I think. Okay, but you still want to measure the voltage for each of them. So for example, for this one, when you measure the current, you will do same thing for this here. Right? So you want to put your ammeter in series. So you want this is your DMM. And the right side is comp. And the left side is the amp or micro or mini amp pin. Okay, so that will measure the current. And when you measure the voltage, you put your voltmeter in parallel, which with each of the light bulb, and then you can measure the voltage. And then you do same thing for here. Okay, so for this one, it's a little bit different. For this configuration, is 1 light bulb in series with 2 light bulb that those 2 are in parallel. This one is in series with these 2. Okay, so the current will be different for each of them. Okay, so these 2 will be similar, but they may not totally similar. So you still need to measure them separately. Okay, so similar when you measure voltage, you put 1 meter in parallel like this. Okay, so that's how you measure the voltage. Since you only have 1 DMM, so you need to measure the data separately and record the data each time. And when you measure the current, firstly, when you measure the current goes through this light bulb, you want to put your ammeter right here. Okay, so you make sure you disconnect the cable, the jumper, and let the current goes through the ammeter. Okay, and after you measure this number, you connect this back, and you want to disconnect this pin and put the ammeter in between. So then this will measure the current goes through this light bulb. And then you do the same thing. You connect this back and disconnect this part and put ammeter in between. And this will measure the voltage, the current goes through this light bulb. Okay, so that's how you measure the voltage and current for this question. There is another configuration, which 3 light bulb in parallel. If you know how to measure these two, you should be able to measure the last one. All right, and remember, you will have a lot of data from this measurement or from this task. So make sure when you record the data, you put like a data table, which is easier for you to check in the future when you write the write-up, and also for easier for us to check your data. Okay, so after you measure the current and the voltage for each light bulb, you will use a thing called photoresistor. Let me share my screen too. So photoresistor is something looks like this. Okay, so in this is given in your, it should be in your lab case. And what's this component working is it senses the light intensity. Okay, so when the light intensity changed, the resistance of this component will change. So what you will need to do is you will, first of all, to get better data, you want the face of this component or the top of this component face to your light bulb. Okay, so that's easier for it to sense the light density. And or if you can't do it, you can like find something to cover the circuit so this thing can work better. Okay, so what you will do is you will let this component face different. So for example, for this one, you will let this photoresistor face this level first, and you measure the use your DMM to measure the resistance, and then record the data. And then you let the photoresistor face to this light bulb and record the resistance for this light bulb. Okay, so you will know you will see the resistance is different when the light intensity is changed. And also when you measure this, you want to put these two components very close together. Okay, so you don't like put them far away. So it's hard for this photoresistor to detect the light density. You want to put these two things very close together. All right. I think that's all for today. I think since this is the first time you will use the breadboard, and also the third task, the circuit is kind of complex. Just let me know or let other UT know when you have trouble to build the circuit or have trouble to measure the current or voltage. All right. One last thing, maybe I can show you how to use the waveform. Okay, so after you open your waveform, something looks like this. Okay, so the wave gain function is control the output from W1 or W2. Okay, so you can say those are the parameter you can change. You can change the waveform to triangle wave or sine wave or even pulse wave. Okay, and then you can change the frequency, change the amplitude, and change the offsetting here. All right, and then the voltmeter. Okay, so that's what you will need to use in task 2. Okay, you will use AD2 as voltmeter. So that's where you can find the voltmeter. Yeah, I think that's all you need to know for today's lab. Okay. Any questions before you start doing the experiment? Yeah.
Is there a output for the lineup?
No. Yeah, so good question. So for lab 2, you will not have the template for your write-up. Okay, so you will do something similar with what you've done in lab 1, but there's no fixed write-up. And pay attention on your format. When you have like graph, you make sure you label your graph and put a title of your graph, similar for the data table. And also when you include the circuit schematic, you want to draw your own circuit schematic. Okay, don't directly screenshot the circuit from the lab menu. All right. Any other questions? If there's no questions, you can start doing today's experiment. One thing I forgot to mention in task 2, you will use a resistor. Okay, so I think you can find how to raise a color code for resistor in the email I sent out I think early this week. So each color represents the different meaning. for the resistance, okay. And also for task 3, you will use light bulb. And if you can see here, this is the light bulb looks like, okay, so don't use the LED. Okay, so the little white thing, so that's a light bulb, okay, so. All right, so if you use LED, you may short the circuit, okay, since there is no resistor. And the photoresistor is something like this. Okay, so I'm not sure how to say this. Okay, something like this. And when you measure them, you want to let the top of this face the light bulb together, like something like this. Okay, you want to make sure they are very close together. That's how you can measure the resistance